All right, I have a weird camera, so let me step back. All right, so welcome everybody. We are in Jefferson City, Missouri at the local Boys and Girls Club. And we'd like to welcome you and thank you for joining us and sharing in with this activity. We kind of started a little bit. Everyone has their laptop and we logged in to SketchUp just so they could see what it looks like. But the speaker tonight is Dr. Amy Elliott of Oak Ridge. Let me take this off. I don't know if you can hear me. Oak Ridge National Lab in Tennessee. And I'll kind of let her go into if she wants to talk more about her fabulous background. I've learned a lot from her about 3D printing, and that's what we're going to talk about tonight. Really is the design side more than the 3D printing, I think. Computer aided design. So thank you guys for joining us, and I think everybody wants to hear her more than me. So you guys,
great.
everybody wave, hello.
Good to see y'all. So we have a lot of different schools here, or a lot of different locations, I should say. We are about 4 minutes early. Should we wait for 4 minutes? We have some, let's see, there's a couple other people I don't see on the screen. I just don't want to miss anyone. So I think, let's see, Katie, Amin, and Rebecca Kennedy. We want to make sure that y'all are ready for us.
I'm ready. I'm an observer. I'm part of the Teen Science Cafe network, so I'm in the background.
Okay, and then let's see, Sandy Hudak, is your group ready? Yep, I see some waves. All right. And then I think we were expecting a couple more though. I just didn't want to start without everybody. Okay, so Rebecca's ready. All right, well, we can start 3 minutes early. That shouldn't be too much lost time. So, well, I am so excited to meet with y'all tonight. This is so cool getting to meet with people from all over. I think we have at least 4 different states here. So I'm from Tennessee, East Tennessee. I know Donna's group is from Lincoln, Missouri. We have another group from Colorado, and I've already forgotten the other group, but we have lots of different people from all over the US, which is super exciting. I love technology. So let me go ahead and share my slides. So you have something to look at. All right. Okay, so tonight I'm going to be talking about additive manufacturing. All right, so you may be like, that sounds super boring, and it is a very boring way to describe 3D printing, but in the field of manufacturing and manufacturing research, we call it additive manufacturing. That makes it sound a little more fancy, I guess. So the reason we call it additive is because we're actually adding material layer by layer, and we're going to talk all about that tonight. So yeah, I work at Oak Ridge National Laboratory in Knoxville, Tennessee. And I started in engineering in high school, and the only reason I ever considered engineering was the FIRST robotics program. Has anybody heard of FIRST robotics or participated in FIRST? Let's see a couple hands. Awesome. So I love FIRST robotics. The actual reason I joined the team though was because my older brother was on the team 2 years before me, and he got to go to Florida for the competition. So way back at the beginning of FIRST, all of the nationals every year was in Orlando, Florida at Disney. And so that's what got me to the team. I wanted to do that. And then when I joined, I decided I wanted to see about this robot design stuff. And so I started designing for the game that we were playing that year. And this mechanism on the top right here was the thing that I designed. And I made it out of like foam board and push pins. I like just cut it out and, kind of made a little paper doll with it and gave it to the engineer. And the engineer came back, a few days later with my design in metal. And that was the coolest feeling in the world, to actually design something and have it out of metal and see it work on the robot. So I was sold. So my mentor said, hey, this is called mechanical engineering, and you'd be really good at this. and it makes a lot of money. So I was like, say no more. That's what I want to do. And so I went to undergraduate for bachelor's in mechanical engineering at Tennessee Tech. I chose that school. It's a really nice kind of small school, very focused on engineering. So it was an easy transition for me from a small town. And then it was also the cheapest option for me. So that was, a big factor. So I grew up with 5 kids in my family, and, neither of my parents had college degrees. So I had to be, a little careful with where I went to school. So, and not to say that you should, you can always take out loans, but that was where I was at. So yeah, I really enjoyed the hands-on part of it. So in school and, after I did first robotics in high school, I did Baja SAE in college, where we did, you can see the picture on the bottom right there in the water, where we built this ATV and we raced it and went in the water, and it was so cool. And I got to drive in that competition because I was negligible mass back then when, compared to the guys on the team. I also interned at NASA. So that's one really cool thing about getting a degree in science or engineering, is that you get to do internships, paid internships in the summers. And so I got to do my paid internships at NASA, and it's a great way to save up some money for the school year and then also get some really cool experience. So one of my NASA internships, I actually got to apprentice a machinist, and I learned how to use machine tools like the mill and the lathe and make metal parts on my own. So I didn't have to rely on the shop. I could just make the parts by myself, and I got to do some robotics internships. So that's me with Robonaut and at Johnson Space Flight Center. We got to go to JPL, MIT, and lots of different places where they studied robots. So that was really fun. In grad school, I had some, I'd gained the reputation of being able to build things. I always got the nickname MacGyver wherever I went. I think you guys are probably too young to know who that is, but basically I was known to be able to build stuff and fix stuff. And so I was project lead for this really cool project called the Dream Vendor, which is the world's first 3D printing vending machine. So we had these really old 3D printers now that would actually print on a conveyor belt and then spit the part off when it's done. So we put that in a kiosk and then made a little interface for the user to put the SD card in and print the part. And so voila, we actually got a patent for this, which is really cool. And then, yeah, you don't need to see that, but one of the coolest things I got to do was be on a reality show called Big Brain Theory. So here's the trailer for that. I don't know if you can hear the sound, I'll turn it up.
Some of the brightest minds in the country are about to go head to head.
I'm a spacecraft engineer.
I'm a graduate student of mechanical engineering.
I'm a rocket scientist. I work on nuclear reactors for the US Navy.
I get excited about building giant robots.
They'll attempt a series of mind-blowing challenges designed to discover the next great American innovator. If the payload gets through, it is going to be messy. God, they'll live together. Work together. It's on me. I haven't anything up yet.
All right, there's a bit of drama.
I still need your help welding this. And I'm not going to let this team fail. One will be eliminated. Judges, have you reached a decision? Until one rises above the others to claim a $50,000 prize and a dream job of a lifetime. I'm Cal Penn, and this is the Big Brain Theory.
All right. So amazing experience. Who would have thought I would never have thought I would be on a reality show. Funny story though, when they put the casting call out, it was originally called Top Engineer. So I would have never applied for a show called Big Brain Theory. That's kind of a weird title, but very unique experience. And you can actually watch the show on Amazon. I think it's really old at this point, but you can still find it there. So Big Brain Theory. So 10 contestants, 8 challenges. We got to build some amazing things like this waterfall elevator there. So they built this waterfall, and then we had to harness its power to rise a person 2 stories up. And so I actually ended up getting 2nd place in this competition, which was a lot better than I thought I would. So I actually almost didn't go on the show because I was afraid I would do so terribly. So it was a great experience. And so when I got 2nd place, actually, Buzz Aldrin, whose picture is there, he was the guest judge for the final competition. And so he saw I got 2nd place, and he took me by the shoulders and he said, "I know what it's like to live in the shadow of another," which was pretty crazy because, Buzz Aldrin's the 2nd man on the moon. And so when I got 2nd place, he kind of like equated me to himself. And I thought that was just the coolest thing ever. So I'll take 2nd for that any day. So great experience. I have a TED talk on the experience. I learned some really amazing lessons just being in that atmosphere of, we not only had to design things. So normally engineers we normally just design things. Like we don't normally build stuff. And that's actually, it's kind of necessary, I guess, in some ways. But if you actually end up working on your design by building it, there is so much that you learn about how to redesign it just by having your hands on it and working with it like that. And so in my TED talk, I talk about the need to reunite engineering and manufacturing. And so have the engineers build stuff, and then power of pure focus. So we didn't get to play out. We didn't have our phones. They took our phones away. We didn't get to surf the internet. Like all of our time was reserved for the competition. Like we didn't even have to do our own laundry. So it was really a unique situation. And we got a lot done in the 7 weeks of filming. We got to build 8 amazing things that most people don't get to build in their whole lives. So very, very cool experience. And then the vital role of failure and innovation. So to do something cool, like you have to fail at some point. Like you're going to mess up something, something's going to break, something's not going to go right. And that's just how it goes. And it needs to be more of accepted as like okay, well, we're glad we learned that now versus later, instead of like, oh no, we failed. So I learned a lot from that. So I'm also on a show called Outrageous Acts of Science on Science Channel. And this is a really fun show where we just a bunch of scientists sitting in chairs and we talk about viral video clips and the physics of like, hey, how did that person fall on their face, or, how did she build that really cool thing? So that's a fun show. I was on about 6 seasons of that. So there's also a web series called RoboNation TV that I've been on. But the coolest thing I've done in engineering, I really feel like, is land speed racing with my friend Eva here. So Eva is a very amazing woman who is, just very driven to show how awesome electric drivetrains are, which they are really awesome. So she builds a it's actually considered a motorcycle, if you can believe it. It's just streamlined. So it's a motorcycle with a sidecar, and she sets world land speed records with this thing that she built, this electric motorcycle that she and her husband built. And they take it out to the salt flats where there's a lot of nice long track. So the salt dries up and it's just this nice smooth track for miles and miles, and you can't get that anywhere else. So it's a great place to get up to very high speed. So she's been up to 276 miles per hour. So super duper fast. This last week she was in the salt flats in Australia, and she went with her new bike. The new bike is green. And she went up to like 260. So next year we're thinking she'll hopefully break 300. Me and my husband are hoping to go down there with her. We went with her to Lake Garnier in Australia in 2019, 2019, which was an amazing experience. So anyway, that's just like a whole other story, but it's the coolest thing I've ever done is to go out to the salt flats in the outback of Australia and race with her. So last year, actually, I was one of over 100 women in STEM honored at the Smithsonian with a life-size statue of me. So they did this survey that said that in major cities, there's only about there's less than 6 statues of women in major cities, and none of them are real people. So we need better role models in the form of statues. And so they 3D scanned and 3D printed 100 of us women in STEM for this program called If Then. It's a great program. If you look for If She Can See It, Then She Can Be It with AAAS, you can pull up all of these resources to learn more about women in STEM and role models. So you should Google that later. yeah, that was really cool. So when I was scanned at the conference, I was pregnant. And then by the time they printed the statue and put it up in the Smithsonian and had my baby, so I got to go see my statue and pose with it next to my baby in the Smithsonian, which was really cool. I'm also working on a kid's STEM book that will hopefully be out soon. Oh my goodness, it's hard to publish a book, I'll tell you. But the main character is Amelia Gearhart, and she talks about how electricity is made and all the STEM and trades that go into it and lots of other things. So I've also published a book on additive manufacturing. Remember, I said additive manufacturing is just a fancy word for 3D printing. But this is some design guides for engineers who want to learn more about 3D printing. So let's talk about 3D printing then. So the first 3D printing technology is a process that we call vat photopolymerization. So this was actually invented 36 years ago, a long time ago, and it was based on materials called photopolymers. Has anyone heard of a photopolymer before? Do y'all know what photopolymers are? So photopolymers are liquid plastics that start as like this liquid goo, and then when you shine UV light on them, they solidify. So this technology used that with a laser. The next technology was inkjet. So just like you inkjet ink on a piece of paper, this would jet binder into a powder bed. So you'd spread a layer of powder, you'd put the ink in it, the binder, the glue, you drop it, more powder, more glue over and over again. And then when you're done, you have these parts that you can unbury from this powder bed. So there's actually 7 different types of 3D printing. So we started with that vat photopolymerization. Then there was the binder jetting, and then all of these others came out. And the one that you're probably most familiar with is called material extrusion. So that's that MakerBot kind of printer, right? The one with the nozzle in it, where you're taking that spool of plastic, and you're pushing it through a hot nozzle, just like a hot glue gun, right? But there's actually 7 different ways to 3D print stuff. And so how does it work? So you have to start with what we call a CAD file. So CAD, C-A-D, that's an acronym. It stands for computer aided drawing. And you cannot 3D print without a CAD drawing. So that's actually a really good skill to learn, is how to draw CAD. How many of you have done CAD before or drawn something in 3D online? Awesome. Okay, good deal. So we're going to learn a new software package today called SketchUp that I love to use. It's not exactly great for 3D printing sometimes, but it's actually really simple for me at least. So we'll learn that one today. So we take our CAD file, we turn it into kind of a simpler version of that. So it's called a faceted model, or an STL. So when you make a CAD model and you're done with it, you'll export it into an STL. And then we give that STL to what's called a slicing program. So this could be Repetier or Cura. You might have different slicing programs. There's a lot of them out there, but it'll take that STL and it'll turn it into a bunch of digital slices. And then each of those slices gets turned into a tool path for the machine to follow. So when you put the STL into your slicer, what you get out is called G-code. So the file extension will actually say .G-code. And that is, and if you were to open up the G-code, it's just a bunch of coordinates. And so that will tell the machine, that's the instructions that machine uses to print your part. So you put that G-code into the printer, it follows the tool path, and then it prints your part. And that's how it works. So why do we want to use 3D printing? Well, there's a lot of reasons, but some of the major reasons are, first off, you can make shapes that you can't make any other way. We say complexity is free. So that means if I want to make something really complicated, it doesn't really take a lot. My machine will see something like this that looks really complicated. When you turn it into a bunch of 2D slices, let's imagine cutting this thing through the middle. It would just end up being a bunch of like circles and ovals, right? Pretty simple. If I were to try to carve that out, though, out of a block of material, forget it. I couldn't get my tool into all those nooks and crannies, right? So that would be really, really hard, probably impossible for what we call traditional machining or subtractive manufacturing, but really, really easy for additive manufacturing or 3D printing. So that's one great reason to use it, is you can make very complicated things. So here's an example of those types of things. So this cool robot hand has this really nice fine mesh structure that makes it really, really lightweight, but very strong. And then this tool over here, that's actually an injection molding tool for a cup, has these little holes inside that let water come through and cool it down really quickly and make it work a lot better. Another reason to use 3D printing is that you don't have to make the same thing every time, do you? The printer is always ready to print whatever you need. It doesn't have to be the same thing every time. So normal manufacturing, though, generally you are making the same thing every time, and you've done a lot of work to set your process up so that you can make that one thing really well. And so if you need to make a second thing, there's a lot of things you have to do to switch over the machine. With 3D printing, you don't have to do that. You can print, a different part every time. You can even print 2 different parts in the same printer at the same time. So that's really great. You can also print things with no assembly required. So like this bike chain, if you just get the clearances between the pins and joints, then you can print this and it works just like a normal bike chain. You don't have to assemble it. Same thing with this like air duct here. Normally air ducts for like aircraft are lots of pieces with fasteners, and we can turn that into one piece with 3D printing. There's a lot of other things you can do, these cool shapes. So this is a sculpture that's actually described by a math equation. So the sculptor, her name is Bathsheba Grossman, and she's a mathematician, and she uses programming and math equations to do her sculptures, which I think is really cool. So this is one of her math equations in a 3D printed bronze sculpture. So you can actually buy these online. I think she has a few on Shapeways, but then she has her own website as well. It's a good Mother's Day gift. Okay. And you can also copy things. You can use a 3D scanner to scan something and then print it out. So there's a lot of uses for 3D printing. Obviously, medical is a big one. So implants, prosthetics, any kind of dental, because all of our bodies are different. And if you want to make something for someone's specific body, it can be really hard. If you use a 3D scanner, though, you can actually use 3D printing to make a custom implant. So like this gentleman here who has this prosthetic, he had a disease where they had to remove half of his face. But with 3D scanning, they could scan the good side of his face and then mirror it and 3D print a prosthetic that matches. And then kids prosthetics. So these kids who are born without their parts of their hands, they need the prosthetic, to make up the rest of their hands. And the kids' prosthetics are really heavy and really expensive, and they outgrow them really quickly. So being able to print a prosthetic at home for your kid is really great. And then how many of you have heard of Invisalign braces? Have you heard of them? Okay, great. So Invisalign braces would not exist without 3D printing. They don't 3D print the brace itself, but they 3D print the mold of your teeth. And then they use a process called vacuum forming to melt a sheet of clear plastic and then suck it down around the mold. And then they use laser cutting to cut it out. And so that's how they can give you a new brace every 2 weeks, which is pretty cool. Lots of food printers out there. I'm sure you've seen concrete printing for construction is really cool. A lot of applications in automotive. Fashion is one of my favorite. And one of the things that we work on is actually large scale 3D printing at Oak Ridge. So I said I work at Oak Ridge National Lab in East Tennessee. It's the biggest Department of Energy lab. So I don't know if a lot of people know about NASA, but not a lot of people know about Department of Energy, but we have some really cool capabilities. And so this was the first car that we printed almost 10 years ago, this Stratty. And since then we've done the Shelby Cobra there at the bottom and the Amy House there at the top and the Hummer and the tool and everything. So the next version of it was in metal. So we took metal welding technology on a robot and used it to build parts layer by layer. So we built this big excavator boom using this welding technology. We put it on an excavator and dug around with it, and it worked pretty good. Our bigger machine is called Medusa, and it's got 3 robots all welding together at once. So it's a work in progress, but it's a really cool project to show how fast you can go if you use multiple robots. It's very hard, though. It's hard to get all the robots to work together, but that's part of our research. Let's see, another thing that we do, so I talked about subtractive manufacturing. So this machine has additive and subtractive on the same machine. And what it does is it'll do the additive manufacturing and then it'll do the subtractive manufacturing. And you don't have to move the part in between, which is really cool. Actually, setting up a part to be machined with subtractive can take a long time because you have to get it precisely clamped in, and it just takes a while. But doing it this way, you don't have to do that because the part's already in the machine. So right after you print, you can machine. So you can see there that we printed it and now it's being machined. Let's go ahead and skip along. Okay, so I'm going to talk a little bit about metallurgy or metals. It's a whole field of science on its own, and it's really, really fascinating. Have you guys ever noticed metal that looks like this? It's very blotchy. It's called galvanized steel. Have you seen that before? So actually the blotches that you're seeing on that metal are different grains. So kind of like grains in a piece of wood in a tree, right? You can see the grains in the wood. It's similar with metal, except there's some talk of atoms. So like metal atoms will actually arrange themselves, organized structures. And when you get a metal to solidify, so it's molten and it solidifies, it'll form these grains. So they're just a bunch of these crystal structures that are just in orientations. And that's why they look we can see them here. Now, the grains of metal actually determine what the properties are. It'll actually determine how strong it is, how ductile it is, and a lot of other properties of the metal, which is super important. You know, there's actually a lot of different metal alloys out there, and they're picked for specific reasons. I'm sure you've heard of titanium. Has everyone heard of titanium? It's very strong. Yeah, awesome. Yeah, it's very strong. So they use that on airplanes because it's very strong, but also very lightweight. Now in buildings though, we use steel because it's very, very strong, but it's a lot cheaper. So that's actually a property there is the expense. And so all of these materials have different properties, and grains are a big reason why. Okay, so one thing that we've been able to do with 3D printing at Oak Ridge is control the grains, which is crazy. No one has ever been able to do that. So this picture here is different colors of grains in different orientations. And we've been able to spell the letters DOE for Department of Energy in the grains of the structure. Now, this is a very, very small picture. This picture, I think, is about less than an inch wide. So you can see this is a lot of detail, and the first time this has ever been done. So this is really, really cool. If you want to learn more about metallurgy, there's so much information online, and it's a really great field to study. My technology that I work on is a metal technology that's inkjet, just like we talked about before, printing ink into the layer. So we've spread metal powder down. We're using an inkjet print head to shape the layer, and we do that over and over and over and over again until we're done with the print. And then we put it in a furnace and we fire it like a piece of pottery. So there's a lot of cool things we can make. We can make that tool, lots of different things. So that's the end of my slides for that part. I have a few more, and I was wondering how we were doing on time. If we have enough time for the demo. So sorry, Donna, to make you get up. I just wanted to make sure.
No, I was just going to say that our kids leave within the next 15 minutes. So
Okay, great. So I'll skip the next part and we'll go ahead
and other groups.
Okay. So if you don't mind, Donna, to leave it unmuted so I can hear people's responses. Is that cool? Okay, great. Because I want to get some feedback on what's going on. Okay, perfect. Okay, so everybody, well, if you don't mind going to your internet browser and look up SketchUp. So it's like ketchup with an S in front, and see if you can get here. And when you get there, say, hey, we're here, or wave. Okay, so one group has not got it, so that's okay. You can just watch. Okay. People with laptops, how are we doing? Good? Okay, see thumbs up. All right, so I'll just say that if you don't get to follow along today, there are tons of tutorials online at SketchUp. You just poke around SketchUp, you know, just poke around this website and there are tons of tutorials also on YouTube. So you don't necessarily, if you don't catch it today, it's not like you're gonna miss it. So, okay, so I want you to go to SketchUp Free. So that's products and SketchUp Free. And start modeling. All right, so easy peasy so far. So the cool thing about SketchUp Free is that you get to save your files online, which is really handy because I seem to lose files all the time. So, all right, so you can see kind of my different projects here. So create new. And then you'll get this screen here. So I don't know who this dude is, but he's got a cool dinosaur shirt. All right. So I'm just going to keep going until you guys tell me to stop. All right. So the cool thing about SketchUp is that you can work in this area without having to change view. So I'm not sure if you use a different kind of program, but it's a lot simpler than that. Okay. So we're just going to get into it. So let's draw a square. So,
Amy,
yes.
Amy, are we, I can see your screen, but nothing's happening. Like, are you moving your mouse or your cursor?
I am moving my mouse. So you can see SketchUp, but you can't move my mouse. You can't see my mouse.
Right.
Oh, that's unfortunate. I'm not really sure how to correct that. So let me try again. Let me just do this really fast. So R for rectangle, 1, 1. P for pull, 1, enter. We're going to draw some circles. With C for circle. We're going to draw a R for rectangle. P for pull. We're going to pull the eyes out. We're going to push the mouth in. We're going to give them some ears. We'll give them a little hat here, a little head. We'll give them another ear over here. All right. So I know we don't have time, but if you go through the tutorials, you'll be able to do this pretty easy. One of the things that you can copy things pretty easy. So I'm going to highlight this and hit the N button for move. Hit the control button as you move them over, and now I can have 2 eyes the same size. Okay. All right. So how do we get this file to a 3D printer? So, like I said, make sure your file doesn't have any walls missing. So sometimes it can happen that you're missing a wall. You got to make sure you have all your walls, and it's called watertight, that there's no gaps or anything. So if there's gaps, the 3D printer won't be able to recognize it. So if you're missing a wall, just draw a line on the perimeter. Okay. So to get this to a 3D printer, we want to hit the 3 lines over on the left. And then we want to download the STL. Okay. So this is really cool because it's all free. So it's downloaded here at the bottom. So I'm going to open up a different program that I use to slice my 3D prints and to make the file that I need to 3D print. Okay. So it's going to take a second to load.
Thank you.
The robot head. SketchUp's all while it's loading, I'll just show you some more things. You can also paint colors, so you can, add color to the robot. So let's do yellow. Yellow. All kinds of colors. You can even do like brick and like house, like different textures and all that kind of stuff. So, all right, so Cura is open. I'm gonna stop sharing this and I'm gonna share Cura. Okay, have you all heard of Cura before? Anybody? Okay, great, we've got one. Okay, so it's free too. All of the software is free, that's just free. So we're gonna open Cura here. Can you guys see my Cura window with the 3D printer there?
Yes.
Okay. Can you see the robot in there now?
Mhm. Yes.
Okay, great. Okay, so all I did in Cura was use the open button and found my file and then open it up. And there it is. So the fact that I can see it means that I have a file that the 3D printer can recognize that doesn't have any errors. So that's great. Okay, so this is really too big though, so I need to scale. These units are in millimeters. I know that 25.4 millimeters is an inch. So I know I need to scale it down. That's a number that you will learn a lot in 3D printing. You'll never forget how to convert millimeters to inches because it happens so often that you design in inches and the program wants millimeters. So, all right, so we scaled it down. So now our file actually has some red on there. So one of the things about 3D printing is that when you're building it layer by layer and you have an overhang, you need something underneath to support. So that red is showing me that I'm going to need support. So I'm just going to pick one of these profiles. So maybe like a draft with like 0.2 millimeter layers. And then I'll just use the default settings. I'm going to hit the slice button. And once I slice it, the computer is going to show me what it's going to look like. So that doesn't really look like what we asked for, huh? Or what we designed. And that's because the computer actually added these supports for all of these overhanging features. And we can actually just pluck those off after it's done printing. It's kind of hard to pluck off support. So I don't know if you can see my camera here, but like I'm printing these statues of my friends and there's all of the support structure to come off. And it's actually kind of hard sometimes. So I actually try to avoid support if I can. So what you can do is you can go into the settings, the support there, and you can uncheck it and then we'll slice it again and we'll see how it comes out. Now this doesn't have any support and these surfaces right here, the ones that needed support before might not print well, but it's probably going to be okay. Anyway, 3D printing is a lot of experimentation. But all you do from there is you save it to disk and you can save your G code on your SD card, stick it right into your printer. So you do have to pick the type of printer. So there's some settings, but you can learn that when you actually download a slicing software, it'll ask you what printer you have. So, all right, well, that is basically all there is. I'm sorry you couldn't see the first part of the CAD lesson, but I think we have a couple more minutes if anybody has any questions.
She can hear you.
She did. How do I build a roof?
How do you build a what?
Roof.
A roof. You want to build a house with a roof? Okay, let's do that real quick.
He has a box with no top on it. So.
Cool. All right, this is one of my favorites. So let me go here real quick. Okay, so got a box. So there's a couple different ways. So there's one way is to take a line straight up. If you can get it to draw in blue, that means it's straight up. And then you can draw your roof like that and erase and then pull it over. You hit control to make it not empty. Or an easier way, actually, this is my favorite trick, is you make a line across the top and then you select that one line, hit the M for move button, click on the end, and then pull it up in blue.
You catch that?
Yeah, I did.
So draw a line. It does. Okay, draw a line. And
So
Draw your line first. We draw a line first across the box, right?
Yep, across the top of the box.
And you said the letter N as in
In
Nancy?
for move.
Oh, M.
Oh,
So
myself.
hit M, or you can hit the move tools over on the left, I suppose.
Okay. Oh, look. All right, that's cool.
Thank you.
Hold on up. Yeah, absolutely. Okay, I think we're out of time. But thank you all so much for coming. I hope that you look into SketchUp tutorials and get to know it and make something to 3D print.
Thank you.
All right, thanks. Bye.